Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be starting our first notes of Unit 8. So today we're going to be talking about prime factorization. So what is prime factorization? Prime factorization is when a whole number expressed as a product of prime factors. Now remember, a prime number is a number that can only be divided by 1 and itself. Okay, so prime numbers 2, 3, 5, 7. So we're going to break numbers down into things that are entirely prime, meaning they can't be divided anymore. Okay, so let's go ahead and let's take a look at what that would look like. So taking a look at this first problem. So let's take a look at these first couple. So we want to break 63 down. So what I want to think about is what divides 63. Now maybe this is something you're not very good at. So what I suggest doing is just taking 63 and dividing it by random numbers in your calculator so you get a whole number. So what I did is I took 63 and I just tried 9. And it ended up working because I know that 9 and 7 go into 63. Well, 7 is a prime number. 7 cannot be broken down anymore. 9, however, can. What divides 9? Well, 9 breaks down to 3 and 3. So to write out the prime factorization of 63, it's just 3 times 3 times 7. So this note sheet is all going to be about knowing your multiplication and having that multiplication stuff memorized. Okay. Now let's take a look at 98. Now I'll be honest with you, I don't know many things that go into 98, but I do see that it is an even number. And if it's an even number, I know it's at least divisible by 2. So I'm going to go ahead and I'm going to take a 2, and then I have 49. So then what I'm going to do is I want to break down that 49. So 49 is going to break down to 7 and 7. 2 is a prime number and 7 is a prime number. So this cannot be simplified anymore. So the prime factorization I always like to write in numerical order. So I do 2 times 7 times 7. So notice when I wrote it out, I took the end of each of my little extensions. So I went to the very end. And if you in your calculator were to multiply 2 times 7 times 7, you would end up getting 98. Now, let's take a look at 180. So here's a hint for you. If you see that it ends in a 0, that means it's divisible by 10. So I know that 180 is at least divisible by 10. So I'm going to use 18 and 10. Well, 10 I can break down to 5 and 2. 10 can't be broken down anymore. It's completely broken down to 5 and 2. Those are both prime numbers. 18 can be broken down some more. Well, what goes into 18? I see it's an even number, so I can do 2 and 9. So now 2 can't be broken down anymore, so I'm done with those guys. But 9 can be broken down a little bit more. 9 can be broken down to 3 and 3. So you want to go down to the end of each of your legs. And now we want to put it in numerical order. So we have 2 times 2 times 3 times 3 times 5. So we're taking and we're multiplying all of those together. So if you were to multiply all of that together, you would end up getting 180. Next, let's take a look at number 7. I hope you guys like my camels. I think they're pretty cute. All right, let's take a look at 102. Okay, so, that's number 7. We want to do the other one first. Yay. Okay, let's take a look at 45. Here's another hint. If you see that it ends in a 5, then you know that that number is divisible by 5. So in my calculator, I go 45 divided by 5. Oh, okay, sweet. So I get a 9. So 9 times 5 is 45. Now we need to break that 9 down some more. 9 is going to break down to 3 and 3. So now we can go ahead and multiply that out. So we get 3 times 3 times 5. So all I'm doing is figuring out what divides those numbers. Okay? So I look at 87 and gosh darn it, I have no idea what divides that. 2 isn't going to work, right? Because if it were divisible by 2, it would be even. So then I take 87 and I divide it by 3. See, okay, maybe does 3 work? And 3 does work. When you divide by 3, you end up getting 29. So then I know that 3 times 29 is equal to 87. Well, 3 and 29 are both prime numbers. I know 29 seems really big, but we can't break it down anymore. So we have 3 times 29 as our prime factorization there. All right, let's take a look at number 6. So for number 6, we have, again, a number that ends in 0. So if it ends in 0, then we can divide it by 10. So that means when I divide it by 10, I'm left with 11, which means that 11 times 10 gives us 110. Well, the only thing left to do is break down that 10 because 11 is a prime number. So I break down 10 to be 2 and 5. So let's take a look at what's left over. I have 11, I have 2, and I have 5. So I'm going to write that out in numerical order. 2 times 5 times 11. So when you multiply all of those out, you should get 110. Next, let's take a look at number 7, 102. Okay, again, I don't know what goes into 102, but I do see that it's an even number. So 102 divided by 2, I could do 2 and 51. Well, let me try 51. I don't know much about it, so I just started dividing 51. I divided it by 3, I divided it by 5, I divided it by 7, and I kept dividing it, and I could not find a number that divided 51 evenly. And then I came to find out that 51 is actually a prime number. So this is the complete prime factorization, is 2 times 51. That's the best you can do for 102. Now let's take a look at number 8. So I take a look at the number 81, and the number 81 sticks out to me because it's a perfect square. Okay, 9 times 9 multiplies to 81. So I'm going to split it up into 2 9s. Well, I can split that 9 down even more. I can split each 9 down to 3. So then I'm going to take and I'm going to multiply 3 times 3 times 3 times 3. So I'm going to multiply all of those together, and that will give you 81. 3 is a prime number, so I have it completely broken down into primes. Next, let's take a look at 24. So I want to split 24 up. So what divides 24? Well, something I know about is 4 and 6. So I'm going to break down 4. I can break down 4 to 2 and 2, and you keep breaking them down until you can't break them down anymore. 6 can be broken down to 2 and 3. So then when I write it out, I'm going to write out 3 2s and then 1 3. So 2 times 2 times 2 times 3 will give you 24. So let's go ahead and let's move on to kind of how we're going to start using these. So one thing that's really important in the unit that we're doing is looking for perfect squares. So perfect squares are when you take the square root of it, that answer will be a rational number. What is a rational number? It isn't an icky decimal. A rational number is like 2 or 3 or 7 or 22. Okay, nice whole numbers. Rational numbers are also repeating decimals. So if you get like 0.16 repeating, that 6 repeating makes it a rational number because you can write a fraction out of it. Okay, and so a perfect square has a number times itself that equals that number. So I know that doesn't really make sense exactly right now, so let's take a look at an example. So let's write out a ton of perfect squares. So it really helps to have all of these examples written down. Then when you're doing your assignments later this unit, you can go ahead and have the sheet out, and then that helps you identify the perfect squares. So first of all, 1 times 1 is 1. So 1 is a perfect square. 2 times 2 is 4. 4 is a perfect square. And then 3 times 3 is 9. And then 4 times 4 is 16. And so we're just going to go through and make this list. Okay, so 5 times 5 is going to be 25. And then 36. And then 49. And 64. 81. So you can be typing these in along with me if you want. 100, 121, 144. That 21 is really silly looking. 169, 196, 225, 256, 289, 324, 361, and 400. So I want you guys to have these lists out in front of you. So if you don't have your perfect squares identified or you don't memorize what they are, you have them there for you on this note sheet. So you can use that later. So have that out. So let's talk a little bit more about rational numbers. So rational numbers are one that can be written as a fraction, and that also includes whole numbers like I talked about before, 3, 5, 6, or 2/3, or 5/15. All of those are rational numbers. I like to call them pretty numbers because they look nice. Irrational numbers cannot be written as a fraction, and they just are crazy decimals, like pi. Pi is a crazy decimal, okay? It doesn't end. It keeps going on with all of these random numbers that have no pattern whatsoever. And those are icky decimals. So irrational numbers, the decimals don't end, and they don't have any sort of pattern. So that's what makes them irrational. So what I want us to do right now is just kind of plug some of these into our calculators and see if they're irrational or not. So what I want you to do first is type into your calculator the square root of 36. So make sure you know where that square root is. If you don't know where the square root button is on your calculator, come show me. Okay, so I want you to try this right now so you make sure you know how to take the square root. Well, the square root of 36 is just 6. So that means that that one is rational. Then the square root of 24, you type that in, you get a crazy, ridiculous decimal. Okay, so when you get that crazy, ridiculous decimal, that means that number 2 is irrational. I'm not going to tell you what those crazy, irrational decimals are. I want you to be typing in to look for that. Then you take the square root of 25. You get a whole number. What is that whole number? You type it in your calculator and you tell me. But since you get a whole number, it is rational. Now, let's take a look at those last 3 here. Second, you put the square root of 100 in. Well, I look up above on my chart and I see that 100 is one of my perfect squares. And 100 is 10 times 10. So I'll give you this one that it's going to be equal to 10. And I just did that using the chart we just made. So if it's a perfect square, then the square root of it is going to be rational. Well, I look up at my chart. Is 50 a perfect square? No, it's not. So it's going to be irrational. Look up at my chart again. Is the square root of 72 a perfect square? I don't see it on my list. Okay, so when I take the square root, that's going to be an irrational number. Okay, so that concludes your note video for today. Go ahead and show me your completed note sheet when you are done. Thanks for listening.